All right, now we're going to go back to the part that we did in recommender systems of Kate nearest neighbor, of looking at the 1,000 points, and we'll just browse through some clustering of that. Before I bring up PlotViz, let's just get some screen dumps. I should say that we're going to look at two things. For the 1,000 points, we're going to look at the actually three things. We're going to look at the original labeling of Harrington, one particular clustering, and finally, and that was into three clusters, and that's just to show what happens. We'll cluster it into 28 clusters. And here is, on the left is the Harrington's original, no, on the right is Harrington's original assignment of points to clusters. And on the left is what happens when you assign the points using k-means. And as I pointed out, we have here centers. There's a yellow center here, the spheres, a brown center for the brown cluster, and a purple center for the purple cluster. I did not mark centers for the Harrington original labels. And you can see they're actually pretty different, and that's true always of this type of set of points. These are a set of points where there are actually no clearly identified clusters. You can chop them up into three or more regions, each where the points in each region are near each other. And that actually, for instance, in a lot of recommendation systems is all you need, because you're trying to find classifications. And all you need to do for a classification, especially when you have a lot of clusters, 28, where the regions are relatively small for this problem. If you have more points, you need more than 28 clusters. But when you have a lot of clusters, those actually divide the region up into relatively small subregions. And if something is near a point in a subregion, you know it's pretty near, and it doesn't really matter how you do it. So that's a pretty important point about clustering. There are some cases we'll see later on where the clusters are very clear, and some cases like this where you can divide it into clusters, and those clusters can be done actually in rather different ways because there are no clear separations. So if we go to the next slide, actually I've in this case I have got it the other way around with the original labels now on the left and the optimal on the right, with the optimal having the centers. And actually for this, but this is just the same data rotated. And for this rotation, you can actually find that the original labels, which are actually pretty clear, this is effectively the clustering where the z-axis is out of the board. So you're actually projecting on x and y. For the original labeling, that's a very clear clustering. For the new so-called optimal labeling, which is actually technically a smaller distortion and a better clustering, for this particular orientation, that's not true. So that's no longer so clear. But that shouldn't be held against it. If you cluster points in n dimensions, where n in this case is 3, and you project it into 2 dimensions, those clusters do not have to be clearly separated in 2 dimensions, because the separation that makes the clustering can be in the other dimensions. So let's just look at that in the PlotViz, because PlotViz being 3-dimensional will help us do that. So here we have PlotViz. Let's just, actually I need to tile these windows. And now I have a nice PlotViz with 2 clusterings here. I now have the reclustering, which is the so-called optimal case on the left, and the original on the right. And This is the case where the z-axis is essentially perpendicular to the board, and so the original labeling is pretty clearly clustered. I should point out, if you want to learn how to use PlotViz, you need to, when you take the files that are given to you, you need to do the following things. You go through the you load each, you go to PlotViz and you you load each file, then you go through and click axes. You don't really want a picture of some axes in the middle of the graph, so you turn that off. You go into the section that says glyphs. These use glyphs, them little shapes to represent the points, because then the points show up more clearly. And you want to put auto orientation to be true. And that's what I've done there. It was already set to be true, so it didn't actually do anything when I turned it false and true again. If I rotated it, you'll see a difference if I turned it false. And the other key thing is we're going to try to make these two 3D plots rotate together. So for each of the windows, we need to set the camera, use sync camera to be true. That's what I've set there. All right, now let's go for it. We'll go up to the view, set the view to full screen. Maybe we'll get rid of this thing here. And now we have the two cases, the two sets of clusterings, and we can try to examine how they look by just rotating them. And you can see they're actually rotating together. And now we found a case where the optimal clusters, the one on the right, are actually relatively well separated, but the one on the left, the original labeling, is not well separated. We can see here the centers, which are now spheres. And by the way, those original slides we looked at were just screen dumps of this. As we rotate, you can see they go in and out of it. Now we got back to a pretty good separation for the original labels, but not so good for the optimal. And we can, but actually, look, as we examine it, we can sort of see what's going on. And by looking at this, we can find out the characteristics of this data set. And whichever way we do it, it's relatively clear that these data sets are not separated naturally. They're just a set of 1,000 points which fill a region, well, not the total region, but a significant part of the region. And if we cluster it, you do see these nice compact regions. Each cluster is much smaller than the original data set, but we can do that in many ways because there's no clear separations to guide us. All right, so that's the end of that particular set of PlotVizes. We go out of full screen and we'll get rid of that particular picture, and we can actually go back to the PowerPoint. And let me get myself a pointer again. Here's my laser pointer, this little red thing. We have our send. This is just the third view of which is of what we just did by interactively with PlotViz, and this is just the third view showing the optimal on the left and the original on the right.